Okay, so the maths study was a fairly big study. We had about 2,000 items from the current and the reformed GCSEs. We threw in a few international comparisons just for sort of benchmarking. In this instance, we had a load of PhD students, maths PhD students, judging them. As Michelle said, by getting a lot of judges to look at these items and pull their judgments, we sort of get a very clear consensus comes out, rather than just getting 2 experts to look. The PhD students were asked to judge which question is more mathematically difficult to answer fully. Next slide, I'll show you what it looked like on screen. We did about, well, each student did 1,000 judgments, so we had about 43,000 judgments. From this massive matrix of judgments, we fit a statistical model, which basically estimates a difficulty value for every single item that best explains the patterns of which beat which. So we had an estimate of expected difficulty for every item. We also had the non-calculator SAM papers, so the reformed GCSEs, the non-calculator papers were sat by around 4,000 students. So about 500 per paper, because we had higher and foundation tier. So we had some data for those papers to compare to the estimates, and that will be the focus. I'm not going to talk about what we found. That's all already been published in terms of the relative difficulty of different assessments. We're focusing here on the biases, whether items were misconstrued by the judges. Okay, so this is what it looks like on screen. I get, yeah, you can see that okay. We use an online platform just on a web browser, and it just presents random pairs of items. We had the items judged at the level of the part question, so A in this instance compared to A on the right. And they could be any pair of questions whatsoever across any domain, different marks, you know, it was entirely random. The only thing the program does is try to make sure that each item is judged a roughly equal number of times. And their task was just to go, which is harder, which is more mathematically difficult? I think it's the one on the right. Click on the right-hand side. Okay? And they did this a lot. So I'm going to focus on the relationship between our judgments of difficulty and the difficulty experienced when the student sat the papers. So this is just the subset of items from the non-calculator papers. We've got actual difficulty on the x-axis, expected difficulty on the y-axis, and through the middle I've plotted the regression line that just shows the sort of mean relationship between these two measures. And for us, the interest here was, are the items from particular exam boards distributed equally either side of the line? We were looking to see whether there were biases in the judging of particular exam board items. I think for you it's more interesting to sort of think about what caused certain items to lie furthest from the line. So I'll try and run through some examples of that. We were actually relatively content with this. 2 of the exam boards were equally distributed either side of the line. The green board B, a little bit above the line on average, but not very much that we were concerned that there was a great deal of bias in the judgments. So we didn't actually look to try and correct this because the data looked good enough. Also remember, of course, this is a very small subset of the items. We had 2,000 and this was only 160. So here's some examples. These items were judged to be really, really easy. They were 2 of the easiest, and you can probably see why. However, our students actually made quite a lot of errors on them. And I think you can, again, probably see why. There's scope for just making a minor mistake, which gets the answer wrong. So that's one way in which questions can be sort of underjudged in difficulty. This one, I'm not a mathematician, so I thought, what shall I say here? We'll have some maths experts in here who will have thoughts about this. This would just be the very hardest question by our PhD students. I'm guessing because it's multi-step and requires several geometry rules to be applied to get the solution. It was hard, but it wasn't anywhere near as difficult as our judges thought. There were 8 items that the students actually found harder. My guess, you might have opinions on this, was just that a certain number of students knew the rules, and if you knew the rules, you just bang, do them and get the right solution. Right, so a lot of text there actually. I think basically the take-home message is that there aren't really any substantial biases in judging maths items based upon just surface characteristics of the questions. Where there are mismatches, it looks as though they're more likely to be coming from a difference between the underlying maths difficulty and catches, things that catch students out and their application of knowledge. We didn't actually try to do any kind of analysis of to see what effect certain features had on the questions, because there wasn't that much bias in the data anyway. There's not that much to code these maths questions on. You've got marks and you've got the number of words. We didn't want to go down the route of looking at domain, that kind of more cognitive level of analysis. That's not our sort of expertise. That's we were looking just to see whether we could explain any features in the data based on sort of surface features of the questions. And we didn't need to in this instance. It looks as though there's not really any massive bias in judging maths questions. They're just, the questions are just do maths, basically. That's my take.